So oxygen dynamics or oxygen consumption is simply a topic that deals with oxygen utilization or consumption in the body and in various stages. So it shows actually how oxygen is utilized, how it is transported, and how it varies in blood vessels. Actually, it has 5 components, namely oxygen transport, oxygen content, oxygen delivery, oxygen consumption, oxygen extraction. Let's look at them one by one. So oxygen in our body is transported in 2 forms, that is oxygen attached to hemoglobin, and the major carrier here is red blood cell that contains a pigment known as hemoglobin, and it is hemoglobin that attaches oxygen. And usually hemoglobin has heme, which are ferrous components that attach with oxygen to form the so-called oxyhemoglobin. This component transports oxygen to the tissues via blood vessels. And then we have plasma in which oxygen is transported in dissolved form, and it usually carries 0.003 or 3% of oxygen. This means that 97% of oxygen is carried by red blood cell, which contains hemoglobin, a pigment that transports oxygen and gives red blood cell its color. So now let's look at oxygen content, which refers to the sum of 2 means of oxygen transportation in blood. So oxygen content is the amount of oxygen that is present in these 2 means of oxygen transportation. That is oxygen presence in hemoglobin and oxygen dissolved in plasma. This makes up oxygen content. And usually 99% of oxygen is attached to hemoglobin, and usually most of the oxygen content is present in hemoglobin, while only 3% is dissolved in plasma. And 1 gram of hemoglobin can carry a maximum of 1.34 milliliter of oxygen per minute. So, assume you have 10 grams of hemoglobin, that means you will carry 13.4 mils of oxygen per liter at once in just 1 minute. So this is the formula for oxygen content. If you want to calculate it, it is grams of HB. That is, assume you have 10 grams, then you will multiply by 1.34, which is the constant number of amount of hemoglobin fully saturated with oxygen. That is a constant mils of oxygen that only 1 gram of hemoglobin can carry. And then you multiply by saturation. Assume you have 99, so you have to change it into decimal for easy calculation. So it will be 0.99. Then this one here, you will add to 0.003 plus partial pressure of oxygen. We assume it is 8. So the answer you get will be mils of oxygen per deciliter. And just remember that when you're dealing with this calculation, make sure you change saturation to decimal point, and partial pressure as low contribution of oxygen content. So just master this formula, and everything will be smooth. And for veins, and this is the abbreviation for arteries and abbreviation for vein. So when you are calculating, make sure you're basing in one. Usually we calculate oxygen for artery. You know why? Because it's artery that delivers oxygen to the tissues. It's mostly arteries that carries oxygen, but in some circumstances we have mixed venous oxygen, and that being the case, in some situations we calculate oxygen contents for vein. Let's now proceed to oxygen delivery. So oxygen delivery is simply the amount of oxygen that is delivered to the tissue per minute. Remember this, and its formula is DO, which is the abbreviation for oxygen delivery, is equal to oxygen content of the artery, remember A, times Q, where Q is the cardiac output. And usually this should give you liters per minute, oxygen liters per minute. But in situation where your oxygen content calculated was per liter per minute, then your formula changes to oxygen delivery is equal to oxygen content in artery times cardiac output, then you multiply by 10 to change it to mils. So your results will be mils of oxygen per minute, because we always deliver oxygen to the tissue per minute, and it's usually in mils. And remember that oxygen delivery to tissues is affected by 3 factors. That is so-called cardiac output. We have hemoglobin, and we have saturation. So if you increase cardiac output, when there is increase in cardiac output, there is increased. When there is increased cardiac output, there is increased oxygen delivery. Similarly, when you increase HB, there is also increased oxygen delivery. And when the cells are or hemoglobin carrying oxygen is well saturated with oxygen, that is, your saturation is at 99%, then automatically even oxygen delivery to tissues is increased, and vice versa is true. So oxygen consumption, abbreviated as VO2, is simply the amount of oxygen that is consumed by tissues per minute, and it's simply the difference between oxygen content in the veins, in the arteries, and oxygen content in the veins. Then you multiply this by cardiac output. So the formula reflects that oxygen consumption, which is VO2, is equal to cardiac output times oxygen content in the arteries minus oxygen content in the veins, and this gives you liters per minute. If you want to change it to mils per minute, you will have to multiply by factor 10. That is cardiac output times oxygen content in artery minus oxygen content in veins times 10. But the last part here is oxygen extraction, which is abbreviated as ER, which simply refers to the ratio of or percentage of oxygen delivered to the tissues and what is consumed by the tissues. Simply, ER is VO2 over DO2, where VO2 is oxygen consumption over oxygen delivered, and usually it is presented in percentage or ratio. And just capture this hint that if there is a drop in blood, let's say there is hemorrhagic shock or severe bleeding, the ER, so-called extraction, will increase to compensate the amount of oxygen needed by the tissues. Also, when we have increased metabolic activities like running or during football match, what happens is that oxygen extraction will likely also to increase to help in compensatory mechanism, that is, give more oxygen to the tissues so that we can function perfectly. As you all know that oxygen is responsible for breakdown of carbohydrates or glucose components into energy, water, and carbon dioxide. So when doing your calculation, remember the normal ranges, as you can see in this table here, and these ranges here are for a healthy adult. So in case there's any deviation, you will see what to fix, maybe increase oxygen support for the patient or positioning. Yeah, that's all it is about oxygen dynamics. Thank you for watching. Do not hesitate to subscribe and stay tuned for other videos.